Let's talk about adding and subtracting rational expressions. If you have not yet done so or need a refresher, go back to rational expression basics to make sure that you have the general kind of starting basis. But adding and subtracting rational expressions, fractions that have algebraic expressions within them. So the first thing is just you're not going to just add the numerator plus numerator and denominator plus denominator. So the first thing you have to have a common denominator, so the denominators have to match. The way you get that if they don't match is you start multiplying the top and bottom of the terms that are being added or subtracted. So you multiply the top and bottom by the same thing, by whatever factors are missing from that fraction's denominator that are in the other fraction's denominator. Once you have the same denominator on each, then you can add, and you add the numerator plus the numerator, but the denominator doesn't get added to it. It just is the denominator that's on both fractions. So the process, the steps you're going to do. So first step, get the common denominator. The way you do that, factor the denominators, and then you multiply the top and bottom of each term, each fraction that's being added. Multiply the top and bottom by whatever factors are in the other denominator that are missing from that denominator. So you do that to get the same denominator on both. Then you're going to expand out the new numerators, so multiply whatever expressions are there being multiplied. Then you can add and combine like terms on the numerators, making sure if there's subtraction, that's going to apply to each term of the numerator of the fraction that's being subtracted. And then you can also check then, this doesn't come up a lot, it's probably not something to worry about, but it's possible that then once you combine the numerators, then that result could be factorable and have a shared factor with the denominator. So if you end up with pretty much, come up in MATLAB, and it might say your answer is correct, but it's not fully simplified, then that would be a clue to do that. But it's rare enough that it's probably not something you need to try real hard to check for every time. So some examples. So this first one, 2x squared minus 4 over 2x plus 5 plus x plus 3 over 2x plus 5, we already have matching denominators. So I can just go ahead and add the numerator. So we have 2x squared minus 4 plus x plus 3 all on top of 2x plus 5. Combine like terms, we have 2x squared plus x minus 1 over 2x plus 5. That's the final answer. Next example, 2x over x minus 3 plus 5 over 3 minus x. These aren't quite like terms. We have x minus 3 and 3 minus x. When you have subtraction in opposite order, the 3 minus x is really negative x plus 3, which is the negative of x minus 3. So I can change that to, one way to think of it is this is 2x over x minus 3 instead of plus minus 5 over x minus 3. So if we're changing the applying a negative. So this is 5 over negative x minus 3. Could be written as minus 5 over x minus 3 or as plus negative 5 on the top, x minus 3. But that might actually be the best way to do it, is just putting that negative onto the 5 on top. So then we have the matching denominators, and we have 2x minus 5 when we combine those over x minus 3. All right, then we get a little bit more complicated here with non-matching denominators. So keep in mind, again, the whole denominator, if there's no multiplication happening, the whole denominator is a factor. So we need to have both of those. So we want to have x plus 4 and x minus 2 on the bottom on both of those. To get that, then we need to add on this first one, there wasn't an x minus 2, so we're multiplying the top and the bottom by x minus 2. And then for the second one, we had x over x minus 2. We need the x plus 4. So the denominator on the result is going to be the x minus 2 times the x plus 4. That's not changing anymore, but I need to do some work on the numerator. So I'm not going to rewrite the denominator each time. But so this is going to be foiling out here, x squared minus 2x minus 3x plus 6. And then this is going to be plus distributing the x squared plus 4x. Combining like terms, then I have an x squared and another x squared, so 2x squared, and then a minus 2x minus 3x and plus 4x combined to a minus x, and then we have the plus 6. And that's the final result. All right, and one more example. Here we have to actually factor the denominators to see what common factors might be there or what factors might be missing. So this is 3 over x times x plus 1, and I'm going to leave some space for that multiplication I might need to do. Minus, and we have x plus 4 over, this is x plus 1 times x plus 1. And actually, while I'm at it, I'm going to change that minus to a plus and with a -1 factor. So I'm so that I don't forget to apply that negative. But okay, so we have x, what we need in the end result is the x and the x plus 1 and the second x plus 1. So the first fraction here is missing the second x plus 1. So we need to multiply top and bottom by that. And then the second one is missing the factor that's just x. All right, so distributing then we have 3x plus 3, and then I'm going to actually combine the x and the -1 together. So that's negative x times x plus 4. So that's going to be minus x squared minus 4x. And so we have then the negative x squared, and then combining the 3x and the minus 4x minus x. And then the plus 3 for the final answer of negative x squared minus x plus 3 all over x times x plus 1 times x plus 1. Or you could write that as x times x plus 1 squared on the bottom. So that's adding and subtracting rational expressions.